Is my document visible to you girls?
Yes, ma'am.
Yes, ma'am.
Yes, J tree. The next component which we are going to study under the Sphinx is the J tree. Right, so it provides you a hierarchy tree-like structure. It's like something like a hierarchy representation which you get your folders at your left side of your directory representation. In a similar way, you can represent a tree-like structure using a J tree component. So this is how the things which you can represent, the folder representations which you will be getting right onto the left side. So that is what a tree which you can construct. So different types of files you can put it, and you can also create subfolders and all, and create a tree like architecture, tree architecture using a J-tree component. So it's not only a J-tree which is present. Under the J-tree you're having different set of classes. So to construct J-tree and also the next components, that is J-table, you will be having lot many other classes. It is totally a separate package is there for tree. Okay, a separate package is there even for a table, because lot many classes are methods are there which are needed to run your tree and your table, right, which we are going to next, the next two components. Right, so a J tree looks something like this. So here the first one is a root, so under which you will be having different nodes over here. A, and under A again you are having a nodes A1, A2 like that. Okay, so you can create what should be the root node, what should be the sub node to that, and what should be the child nodes for what. You can decide it using different classes. Okay, so let us see what does it represent. A tree is a component that presents a hierarchical view of the data. So to know represent your data in a hierarchical format, you can use this J tree. The user has the ability to expand or collapse the individual subtrees in the displays. Trees are implemented using a Sphinx by the J tree class. So to implement the trees, we need J trees over here. So you can expand and contract something like suppose if I'm going to my PC, so whatever I'm having, so this is like a tree which is having. So if I just see, it is collapsing and it is expanding, right? So this is something like a tree like architecture which you can construct. Here left hand side, how I am getting the access. So if I click on this arrow mark, it is providing me the list of things, and again if I click on that, it is just compressing again, right? So expansions and compressions of your tree can be done using your J-tree component, and it is present into the javax.swing. J-tree is a class defined into javax.swing, and it is inherited by your J component. That is a superclass for the J-tree is a J component. So that's why it is a lightweight component. And all the classes required for running this J-tree are present into the javax.swing.tree. Only the J-tree class alone is present into javax.c, and all the remaining classes and functions which are required to run your J-tree are all present into javax.swing.tree, as it is a sub package under the Swing. So you have to exclusively import that package if you want to create a tree component. And it depends on two models. The the J tree depends on the two models for its working. One is a tree model and other one is a tree selection model. A J tree generates a varieties of events based on what type of operation we are doing on it. Is it selection, or is it expansion, or is it compression? Based on what we are doing, the types of the event will be generated over here. So the three events which could be generally handled will be tree expansion event, tree selection event, and tree model event. So tree expansion event is generated whenever a node is expanded or collapsed. Means whenever you try to expand a tree or collapse a tree based on a node, then the event which will be generated will be tree expansion event. You will be having its corresponding listener, tree expansion listener. Right. And tree selection event is generated whenever the user selects or deselects a node within a tree. So whenever user tries to select a node, if you double click, it will be selected, right? So whenever you double click, the event which is generated is a tree selection event. When you deselect also, it is a tree selection event, right? Next, tree model event is fired whenever the data or the structure of the tree changes. So whenever you add a new node or delete a node from a tree, then the structure of the tree is going to be changed, right? So in that case, the tree model event will be generated. So you will be having a corresponding listeners for this accordingly: tree expansion listener, tree selection listener, and tree model listener for us. And all these listeners are present into javax.swing.event class respectively. And the method which we have to implement here is for the tree selection. Usually we go for a tree selection event because whenever we select something only we want to handle usually, right? So if you go with a tree selection listener, the corresponding handler method present in the tree selection listener is a value changed method. Okay, we can also use a method called as getPath to know you which particular node is selected along from the root, and also the path also can be known using a getPath method. So it gives you from the root what is the path to reach the selected node using a getPath method. And it also provides many methods for us. The tree to create a tree, we cannot directly create a tree. We have to create a nodes first and then add those nodes to the tree. So for that we are having a tree node interface over here. So using the methods present in the tree node interface, by overriding that we can create, or else it will be a mutable tree node interface which can be taken over here, which extends your tree node, means which is a subclass. Mutable tree node is also again an interface which is a subclass of a tree node. We can either even use mutable tree node, but it declares that whenever you have add a thing, you can also delete, means changeable. Adding and deletion is possible. That's why it is called as a mutable tree node. So either you can create a class which is inheriting the tree node and try to create the nodes by creating an objects for them, or else you can also inherit a mutable tree node, or else the default class. Both mutable tree node and your tree node are interfaces. So instead of going with the interfaces, if you want to go directly with the class, then you can go with what is called as a default mutable tree node class, right? So default mutable tree node inherits the mutable tree node interface, and it represents a node in a tree. Okay, so whenever you want to create a node, create an object of that particular type, maybe it's a string or whatever it is, name what type of component do you want to add it as a tree node. You create that object and pass it as an argument to this default mutable tree node, right? And after you have created the node, then add it to the tree using the add method, right? Okay, now create a hierarchy of tree nodes by calling the add method, corresponding add method accordingly. If it is to the root, first root, if you're adding all the things, everything will be going into the tree. If you want to have subtrees and all, accordingly you should add the things in a proper order so that you can create the proper hierarchy. Right, so here also we try to put the J tree inside a scroll pane so that the size visibility area of your J tree, which is if the length is, if the hierarchy of the tree is very large, it may be difficult for us to display the things. So if it is restricted inside the scroll pane, the view area of your J tree can be restricted. So that's why we usually create a J tree and create a scroll pane, add your tree into your scroll pane and add your scroll pane to your content pane actually, right? So to create a tree, first we create a nodes and then we add those nodes to your tree, J tree. Here is the constructors of a J tree. First one is a default constructors, creates an J tree with the sample model, and J tree with the hash table returns a J tree where you can pass the hash table. Then with respect to the hash table values, a tree will be constructed. And a J tree, an object array you can pass. So the array of object, you can pass an array of objects, any type of an object. So with those objects, a J tree will be constructed. You can also set a model for your tree, create an object for your tree model and pass it as an argument. Then all your components which you're adding will be with respect to that. And next, root node. You can specify what should be the root for your tree node. And next, tree node, and also asks allows the children, returns a j tree with specified tree node and which displays a root node and which decides whether a node is a leaf node or in a specified manner. So do you want it to be in a specified manner or not? Okay, so it can be check whether that should be a leaf node or a normal node. You can just ask it over here. Asks allows children. If it is allows children is true means it will be a normal intermediate node. If it is asks allows children as false means it will be like a leaf node, right? And you can also create a vector of your components and or your objects and send it as an argument. So with those vector values a tree can be constructed, right? So these are the different constructors. Let me just show you the example how it looks like a tree. So here is our tree demo. I'll just run it out for you first and show you. Then I'll show you explain you the program. See, could you see this, girls? The tree-like structure. The first one I have created my root as the options into which I am having two subtrees A and B. Right. So if I click on A, again I am having A1 and A2, two more nodes. And when I click on B, I am having three more nodes B1, B2, B3. Right. So when I can do both the collapse and expand. So when I expand, I collapse, the tree expansion event will be generated. And when I select any of the thing, selection is option A1. See, it is displayed into the status bar. Option A, options A1. It's a path which is displayed over here from the options to A and to the A1. So if I select B1, you should double click, girls. Okay. So options B, B3 is the path. So path is displayed in the status bar. So whenever you select, it is a tree selection event which is generated and the corresponding handler method is value changed. Okay, so let us see how it is implemented. So as usual inside the init, it's an applet which we are creating. So run it through the applet viewer, girls. I'm calling invoke and wait, inside which I'm calling a run, which calls a make GUI. So inside the make GUI, I have created default mutable node top, which should be my root as with the name options. Then I have created another A1, A2 and I'm added them to the top. A1, A2 should be added to the A1, A2 should be added to A and A should be added to the top, right? So top dot add of A1. So I'm adding A. What is A? The name, the root node, the node with the name capital A, right? So I'm adding it to the top and A1, A2 I have to add it to A, right? So you see the path. A1, A2 I have added to A, right? So A dot add of A1, A dot add of A2. Similarly, I have created B, added B to the top. B is added to your root, right? To the options. So I have added B to the top and I have added B1, B2, B3 to the B. All of them are default mutable nodes. Right, now create an object of tree by passing root as an argument. Right, so it creates now with that root a tree will be created. I'm putting it inside a scroll pane so that if required it will be added. I'm adding that scroll pane to your content. Is it clear, girls, how to create a J tree? Girls, am I audible?
Yes, ma'am.
Yes. So accordingly, whatever the nodes you want to create using a default mutable root node and then add them to your respective folders, parent node hierarchy which you want. In that hierarchy you can add it, and if you want accordingly handle the events also, right? So coming to the next component, complex component is a JTable component. So JTable component is also an additional component which is not there in your normal AWT and is added into your swings. So whenever you want your data to be represented in the form of a rows and a columns, then we can use this JTable, right? So here is a way how a JTable looks like. It also has a headings. If you could see the content in the rows and columns, the data is present. It can also have a headings like name, this is the name, this is the extension, ID and all. So you can also have a heading bar, and below which you can have all your data, right? It is also a lightweight component as it is inherited from the J component. This is a superclass for the JTable is a J component. So it is lightweight component. JTable is a component that displays rows and columns of a data. You can drag the cursor on the column boundaries to resize the columns. So as you do with your normal things, like you can just put over here with your Excel sheets, increase the size of your boundaries and all, you can do it. Depending on its configuration, it is also possible to select a row, column or a cell within the table and to change the data within the cell, right? So it allows you to do different types of events, like you can select total complete row or a complete column or a single cell of a table, and also can edit the data. Means you're also having accessible to edit the data into the table. That is what the meaning over here. All these types of access can be done through the table. So for all of these, you're having so many events which are there, but usually we display the data for your summary sheet and all. Means when we are talking about the GUI, it is actually the result which we try to uh, do. We don't ask user to enter the values into the tables. Usually we take the details in the form of a forms and all. We don't take it in the form of a tables, right? So tables usually will be displayed as a summary sheets and all, and don't usually handle any events. There are different event classes present even with your trees, but users don't prefer to handle events with respect to your tables. Why? Because they just want to use tables to show their summary sheets and all, not to handle any events. Take the input from the events. They don't want to use tables to take the inputs from the users, right? So that's why J table events will be rarely handled. So here we'll just discuss about the different things which can be taken care with respect to the J table. So it provides many features and many functions. It is a complex component in the J swings, but still it is easy for us to use if we just go with the basic things. It has many classes and interfaces associated with it. These are all present into the javax.swing.table. As we are having a separate package for trees, similarly we also have a separate package even for the table. Okay, so all the classes and interfaces related to your Java x.swing table is stored into the this package called as javax.swing.table. It contains one or more columns and rows and cells, and at each top top of the each column you have what is called as a heading, and it does not provide any scrolling capabilities on its own. So if you want to wrap it, you have to put it inside a scroll pane. So JTable also do not provide any scrolling capabilities on its own. So we have to put it onto your scroll pane. If you have to put even your table onto your scroll pane, because based on the entries, if the entries are size, it may occupy more space. To avoid more space, we have to put it inside a scroll pane. And it depends on the three different models. The JTable is executed using three models. One is a table model interface, other one is a table column interface, and next one is a list selection interface. It is the table model interface defines the things related to displaying the data in the two-dimensional format. So how to display the data into two-dimensional format, how to arrange into rows and columns will be taken care by this table model interface. The second one, that is a table column model. It is defined with the terms of the columns, and it specifies the characteristics of a column. And these two things are present into the javax.swing.table. That is, table model interface and table column model are defined into the javax.swing.table. Table, table column model will tell you what type of columns, means what type of values are present into each column, its heading. Just a second, girls. Okay, yeah. So it helps you take different types of how to handle with the different types of data values in each column, and what is the heading of the each column will be represented using a table column interface. And list selection model will determine how items are added, means how do you add entries into your table, and how we can select the entries into the table, that you can know using J selection model. And it generates different types of events like list selection event and table model event. So if you're trying to select or deselect the items, then the event generated will be list selection event. And whenever your table data changes, when you are adding or deleting a column or a row, or trying to change the data in the table, then it is going to generate a table model event. So as usual, as it doesn't provide the scroll pins, we try to create initially a JTable object and then try to add the JTable object to the scroll pin and add your scroll pin onto your content. Here are the list of constructors which you are having. The first one is a JTable default constructors with the default model, and empty table will be created. And JTable with the number of rows and columns, you can construct a table specifying how many number of rows and columns should be there. And next you can pass the objects array, where you can specify the row data and the column names. So this is rows data indicates these are the data of your table, and the column names here indicates the heading, the first heading what should be displayed as your first row. The heading values you can pass this as a separate array, and all the other entries into your table you can pass it as a first two-dimensional array. Next, you can also create a separate model and pass that model as an argument, or else you can pass the table model and the table column model objects separately and pass them as an argument. Create a table using that. Table model, table column model, and list selection model. We can create 3 customized objects for all of these and create a table with these values. And you can also create a vector instead of an array, and also pass them as an argument to create a JTable, right? Let me just show you the execution. See, yeah, I'm creating a JTable using an applet. So in the Make GUI, see what I have done. I have created my column heading as name, extension, and ID is my headings which I am given. And here are my values. I have created a two-dimensional array of the type string, and adding that array data is my two-dimensional array, and column heads is my one-dimensional array where heading is present. So data and columns, I have created a JTable using this constructor, and this JTable I'm adding it into the scroll pane here. J scroll pane, J space equal to new J scroll pane of table. I'm adding a table to the scroll pane, and adding a scroll pane to your container. I'm not handling any events here, girls, just trying to display the contents. See, here is how the table is displayed. Here I'm having how many entries? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 entries are there. So I'm provided with the, as I've added it into your scroll pane, it has automatically provided me the vertical scroll bar to see the remaining entries which are not visible. So the size here is fixed accordingly as the number of entries are less, means with respect to the number of columns. So that's why the horizontal scroll bar is not provided over here, only vertical scroll bar is provided. Okay, so this is how the contents can be displayed. We can also access the contents from your table and store it over here, right? We can read the content, access the content one at a time, or all total table values at a time, or a column wise at a time, row wise at a time, with respect to each cell, like first row, second column, like that, the entry what is present. Individual accessing to each of your table entry is possible over here. And whenever you make any selection, like a row wise or a column wise selection, then it generates the list selection event. And whenever you change the model, like delete a column or add a row or a column, then it generates the uh, table column model. Okay, girls. Yeah. The next component is the menu bars. So I can also create a menu just like the menu which we are having over here in our document, like file, home. There are different menus, and in each of the menu you are having a sub menus. Like if I click on a insert, I'm having lot many other sub menus over here. If I click on file, I'm having sub menus like save as, open, close. If I click on home, I'm having different options like cut, copy, format, all these things. If I click on review, I'm having different options like, okay. So accordingly, you can create a similar type of a menu bar onto your container using this class called as menu bar. And as with your JTree, this is also not a simple component. It is a complex component. Here, why we are saying it is a complex component means it is not the single class which is only required to create a menu bar. We also need other subclasses of it to create the total component over here. So menu bar is on the top, which just creates this menu, this whatever the bar which you could see over here. The first one is the title bar, below which this is what your menu bar, right? So now the home tab is selected. That's why the home related sub menus are displayed for us. So this is a menu bar. So onto the menu bar, you have to add all the menus: file, home, insert, page layout. Could you see this, girls? File, home, insert, page layout, all these are the menus, right? So when I click each of the menu, you'll be getting save as. These are all the menu items. Save and send, print, new, all of these are the menu items, right? So few of the menu items also has icons, few of them don't have an icon. So accordingly, you can display whatever the way you want to. You can also have sometimes a toggle buttons, view, if you could see, sometimes a checkable menu items are also there. Okay, so different types of menu items like checkable menu items, normal menu items, radio button related menu items, all different types of menu items are also related classes are also present. So J menu bar will be onto the top, onto which all these components should be added, right? So here is how a menu bar looks like. So if I click on a menu, it should display the list of items. You can also have a sub menus over here, right? Menu look likes in our Java. A J menu bar is a class used to display a menu bar on a window or a frame. It may have several menus like here file, menu, insert, all these are the different menus. So you'll be having a single menu bar onto which we'll be adding different menus onto it. The object of the J menu class is a pull down menu component which is displayed from the menu bar. It inherits the J menu item class. Okay, so J menu bar is a subclass for the J menu is a subclass for the J menu bar, and it is a drop down menu, something like this. When I click on that, it displays me the list of menu items which are present. Okay, so that's why it is called as a drop down menu component, which is displayed from the menu bar. So it is added onto the menu bar. If you click on that menu, it displays you the drop down menu bar list. The object of the J menu item class adds a simple label menu item. This item uses in a menu's most belonging J menu item or of any of its subclasses. So even J menu item is could be a normal simple label like thing which can be added. So if you want to have a checkable menu item or a radio button type, you are having J checkable menu item and J radio menu item, right? And these menu items will generate the action events whenever a J menu item is selected or deselected. It is going to generate an action event, and it can be handled as you handle your buttons by implementing a action listener and overriding the action performed method. And to do with the radio button type of the menu items, you are having a J radio button menu item class which can generate both action events and item events. Accordingly, you can handle them as you have handled for your radio buttons. And for checkbox menu items, you're also having a J checkbox menu item class. So you can create also a J checkbox menu items which can be handled when they are clicked using that is, they generate the item events, and you can handle those as you handle with your checkboxes. Let me just run it out and show you how the menus will be working. See, I'm doing it through the frames. Remember here, girls, frame is another type of a component. If you could remember the hierarchy, under the component you are having a container, and under the container you are having a both J frame and J panel as a separate things, right? So J frame is a heavyweight component and J panel is a lightweight component over here. What is the difference between frame and panel? I told you in our offline classes itself. Frame has its own borders and window related features, whereas a panel doesn't have its own borders and window related features. And frame is like a top level window, that is you cannot put frame on any other thing. You can put any other container onto the frame, but frame cannot be put onto any other item. That is, they should sit directly onto the desktop. Okay, so that is what the restrictions with the J frame. And J frames, when you are using a frame container, you doesn't need the applet viewer or applet tag over here. You can run it using your main functions, right? So you here is a thing where I have created, see, into the I have created a class with the name JMenuDemo. Inside the main function, I have created an object for the JFrame normal way JFrame with the name title given as JFrame example. I have created a menu bar seagulls. J menu bar MB is equal to new J menu bar. I have created a menu bar object. Then now I am creating a menus. I have created a panel. Now I am creating a menus. I have created J menu with the name menu and J submenu with the name submenu. Two menu items. One is a menu and other one is a submenu I have created. And I have created items for the menus, 5 items using object J menu item class. Item 1, item 2, item 3, item 4 and item 5. I have added 5 items into the class. Okay. And then see, now all of these items I have to add it into the menu. These are the menu items. So these menu items I have added in, I should add it into the menu, and the menu I should add it into the menu bar. See, first I am adding the items into the menu. For I1, I2, I3 I am adding it into the menu, and I4 and I5 I am adding it into the sub menu. And this sub menu I am adding it into the main menu, right? So menu dot add of I1, menu dot add of I2, menu dot add of I3. So I1, I2, I3 are added to the main menu, right? Then I've added I4 and I5 to the sub menu, and see, menu dot add of sub menu. I'm adding sub menu to the main menu, right? So under the main menu, I'm having I1, I2, I3 and a sub menu. And under the sub menu, if I click, I'm having I3, I4 and I5, right? And after this, the total menu, both I have to add the menu to my menu bar. So MB is my menu bar object, right? So MB dot add of menu. Now menu bar is menu items are added to your menu bar, right? And then for this frame, set your menu bar. So frame dot set J menu bar as MB, right? And when you're working with the frames, it's not like an applet and not like a frames which you are having in your AWT. You also you should make your frame visible by calling a method called as set visible, and you're having different operations which you can set the resolution on its own. You can set the size for your frame, and you can set some features for your frame by using a different methods like close on exit, uh, all the related features which you can access through the window can also be present into your JFrame class. Okay, the main thing what you have to remember is you have to make your frame visible, otherwise it will not work. As you are having a applet viewer there to start the applet, here we are having a set visible method to make your frame visible to the user. So you have to make the set visible function as true. You have to pass an argument true to that, so that the frame gets visible over here. After once you say set visible, then your frame will be visible. Otherwise, if you miss this method, the frame will not be visible to the user. It will not be displayed to us, right? Let me just run it out and show you. Yeah, could you see this, girls? This is our frame with one menu which has been displayed over here. This is my menu bar. Lines or no. If I click on menu, see. Into the menu, what are the things I have added? Item 1, item 2, item 3 and the sub menu. So if I go for the sub menu, I'm having item 4 and item 5. Is it clear, girls? Yes?
Yes, ma'am.
Yes, ma'am.
So to create the frames, we just can add any type of the components. Here is one more example of the frame. See, we have created a frame. Inside the main function, just create a frame object. I've created a panel. So I cannot create a frame and put it inside a panel. I can create a panel and put it inside a frame. So if I want 2-3 different groups of components to be displayed onto my window, segregate or categorize my window size left side, right side, then you can do it with your panels, right? So what I'm doing over here, into the panel I'm adding my components, and that panel I'm adding to my frame. So I've added a label, a button over here, label and a button to a panel, and the panel I'm adding it to a frame, setting the size of my frame over here, and I'm saying that default close operation to be exit on close. So it should exit the window on closing, right? And set visible as true. Let me just run it out. See, so a label and a button, I'm adding it on to my frame. Okay, so as you have added components to your applet, so you can add a similar components even to your frames also. Okay, girls, any container, any of the container, you can use any of the container to add your components. Usually with respect to the windows means we use the frames, and that is with respect to the main. If you want to work out, we use the frames, and if it is with respect to the applets means we work with the J applets. Okay, girls, is it clear? Yes, girls, is it clear?
Yes, ma'am.
Other than these, there are also lot many other classes are also which are present, like a J dialogues, and which is another container. As I told, J dialog is a what do you say? It's a small window which displays you the message, like you have used it already in your division program. Let me just explain this part of a code where we are using a dialog. So in the exception, when you raise an exception, when you give uh, other number other than the text, it raises a number format exception for us, right? So when you get that exception, you are showing a dialog box, right? So that dialog box is nothing but it is also a subclass of your window class. Under the component you are having a container, under the container you are having window, under the window you are having both JFrame and JDialog, right? So JDialog is also a window, but it is a less featured window where you can display only limited components and usually used to check the status, like do you want to save or display some pop-up messages, such type of things we use the dialog boxes. So similar way here in our program we have used a dialog box to display a pop-up message whenever an exception has occurred, right? So that we are doing it using this method called as show message dialog. So this generates an option pane onto which a dialog box will be displayed with a message, okay? And whatever the message you are passing here as an argument, with that message a dialog box will be displayed. J option pane is one such component which creates a container for us. A container here indicates a small container which doesn't have any borders and all. It's a pane, simple thing which can hold some containers. So onto which your dialog box is actually going to be displayed, and that displays the message what you are passing as an argument, right? So using you can use the dialog boxes in this way to display the messages. So this is all about your swing components, girls. We are left out with the layout managers. I'll discuss about the layout managers in the next class. Let me just give you the introduction in this class. In detail, we'll discuss it in the next class, girls. So coming to the layout managers, there are 5 different layout managers: flow layout, border layout, card layout, grid layout, and grid bag layout. The default one is a flow layout, girls. Flow layout, card layout, border layout, grid layout, and grid bag layout. The default one is flow layout. What is actually a layout? What is a layout, girls? Let me just show. What is a layout? So when I run my program, see here there are different components for me. Yes or no? When I run my Calci program,
Yes,
there are
ma'am.
different components. Yes, girls?
Yes, ma'am.
Okay, so I'm having enter labels, like 3 labels, 3 text fields, and 4 buttons are there. Okay, the order in which the components will be displayed will be depending on order in which we are adding. So in which order we add the components, in the same order they will be displayed, right? So here, if you could observe, initially when the size is small, first the label is displayed, below which a text box, then a label, then a text field. Yeah, I could see it in this way. But when I increase the size of my label, what is the thing which is happening? All the components are coming in a single line. Yes or no?
Yes, ma'am.
Which one
Yes, ma'am.
sounds better? Which one looks better? The smaller one or a larger one?
Smaller one, ma'am.
Smaller one is more appropriate, right? Even that is also not fully appropriate. Here, if you could see, the buttons are not organized in a proper way. Like, okay, so when you visit a website, when you are viewing the different components like your text fields or some links or some images and all those things, all of them are properly organized and that doesn't move even if you minimize or maximize. Yes or no?
Yes, ma'am.
Yeah. So how this is happening is using the layout manager skills. Using the layout managers. So by default, we did not use any layout manager. And even if you have used, it's a flow layout which we have used till now in all our programs, right? So by default, even if you use or do not use, the layout manager is a flow layout. Okay, what do you mean by flow layout here? Let me tell you. Means according to the size, as I told, each of these components are having their own look and feel. Means if it is a swings which we are using, they have their own look and feel given by the Java. If it is what do you say, AWT, it has a look and feel with respect to the, it has a look and feel with respect to the uh, okay, so it will be with respect to the platform which we are using. The look and feel will be with respect to the platform which we are, where is my applet? Yeah, the look and feel is with respect to the platform which we are using, right? So here, whenever you are running your program, or whenever you want to show your screen on any particular system, if it is to be same, you should arrange your components in some proper order, right? Means you should set the layout. Layout is nothing but the way, or the, these are called as the managers. We all actually call them as a layout managers, right? So they manage the way your components display onto your container. Container means onto your window. So how the component should be displayed? Should it be at the top? Should it be at the left aligned? Should it be to the right aligned? All that alignments. Okay, you can set for each and every component. Means with respect to the each and every component also, you can set the alignments using a grid bag layout. Okay, otherwise you can use some existing templates to display your contents onto your window. See, if you could see our Eclipse editor, here there are partitions. Now if you could see, there are two partitions. This is one and this is one. So I'm using a template where I'm keeping some components onto my left hand side and some components onto my right hand side. If you open any e-commerce website also, all your things are segregated. Left side you will be having filters, above you will be having you will be having different recommendations which you can use. Right side you will be having advertisements which will be helping you to find out more better items, right? And in the center you will be shown with whatever the contents you have asked with, right? So there are differently categorized, so they follow some templates. So similarly here also, there are few existing templates wherein which you can use those templates, and according to those templates you can add on your components. Something like when you are preparing a collage, photo collage చేస్తారు కదా మీరు, చేస్తారా చేయరా image collage?
Yes,
Yes,
ma'am.
ma'am.
Right, so in the image collage, what you will do, you will select some templates and then you will add your photos onto that template. So according to that template only you can add, you can't change the template, right? You have to select one of the template, and once you select this template, you can add the photos into it. You can't change the template format. If you want, there is also customized version template could create చేసుకోవచ్చు. But when you're selecting an existing template, you can't change the format of a template. Yes or no?
Yes, ma'am.
Yes, so
Yes,
it is
ma'am.
something like that. So you're having a template layout managers, like one of them is a flow layout, border layout, grid layout, card layout. These four are the, what do you say, template layouts. And the last one, grid bag layout, is specific to each and every component. You can do it. This is fully customized version which you can make for each and every component, right? And these four are the template formats which can allow you to arrange your components using those templates, right? So in the next class, I'll explain you how the components can be arranged using these file layout managers. Okay, girls?
Okay, ma'am.
1 second, girls. Let me just take the attendance, then you people can leave. 1 second. Okay, girls, you can leave.
share today's and yesterday's class programs,
Yeah,
ma'am?
I'll share you this PPT swing components. Programs also I'll share you. You just
Yeah,
write
ma'am.
out, girls. Girls, you need not write them in. Yeah, one more, just 1 minute, girls. All of you join the NPTEL course. What is that? Programming in Java. It has been informed by HOD sir that you all people have to join the NPTEL course. It is going to it is already started. First week videos and assignments are also released. So do join, all of you. Next in the lab,
Okay,
I'll check it
ma'am.
out whether you have joined or not. కోర్స్ రిజిస్టర్ చేసుకోండి. ప్రాబబ్లీ ఎగ్జామ్స్ ఇప్పుడు అప్పుడే ఉంటాయి. ఇంకా అంటే టైం ఉంది కదా మీకు, అప్పటి లోపల యూ కెన్ కంప్లీట్, యూ కెన్ డూ ఇట్. ఈవెన్ ఇఫ్ యూ హ్యావింగ్ ఎగ్జామ్స్ ఆల్సో జస్ట్ ఇఫ్ యూ స్పెండ్ 1 or 2 hours ఇట్ విల్ బి ఎనఫ్. ఎందుకంటే మీరు ఆల్రెడీ కంప్లీట్ చేశారు కదా. జస్ట్ మేక్ సమ్ గ్రూప్స్ ఆన్ యువర్ సెల్ఫ్ అండ్ ట్రై టు కంప్లీట్. ఆల్ ఆర్ రిజిస్టరింగ్ ఫర్ ద సేమ్ థింగ్, రైట్? సో డివైడ్ చేసుకోండి. ఇఫ్ యూ హ్యావింగ్ ఎగ్జామ్స్ then divide the work, divide your assignments, try to do it and complete the course, get the certification. It will be useful for you. Okay girls, next in the labs, next week in the lab I'll check it out, Monday and Wednesday. All of you should register for the NPTEL course Programming in Java. Could you hear it, girls?
Yes, ma'am.
The course name is
Yes, ma'am.
Programming in Java. Join that course. And coming to the record, you have to write, already I have told you with respect to the threads and all, you have to return producer, consumer and multi-thread, that is printing square and cube of a number. Till that you have to write. And after that, with respect to the applets, write the simple applet. Banner program is there, no? Simple message program, simple applet message program, banner program, key events, mouse events. Okay, key events and mouse events. And then your calci, what you have shown me yesterday, calci factorial division. Okay, is it clear, girls? These are a list of programs which you have to
Okay,
write
ma'am.
in your record. Okay girls, you can leave.
Okay, ma'am.